Mathematicians and scientists, like all people, like to take shortcuts whenever possible. So imagine you're a physicist and you're studying alpha particles, which are clumps of protons and neutrons that are emitted during some types of radioactive decay. See this long string of zeros and all the numbers after that decimal? That tiny, tiny number? That's the weight of a single alpha particle. So now imagine you're writing a report and have to refer to that weight repeatedly and even use it in calculations. Well, that's a lot of writing. Or how about this enormous number? This number is the number of water molecules, little H2Os, floating around in a single drop of water. That's right, a single drop of water has that many water molecules. Anyway, scientists and mathematicians found a shortcut to deal with such tiny and such enormous numbers. Using powers of 10, we can abbreviate these long numbers using scientific notation, which is shown in red. Notice that if the original number is smaller than 1, like in the first example, the exponent will be negative. So we have 10 to the negative 27th. If the original number is greater than 1 in the second example, then the exponent is going to be positive. So we've got 10 to the 19th. Notice which numbers appear in the scientific notation and which numbers don't, namely all of those extra zeros. So let's look at the second example in closer detail. When writing numbers in scientific notation, we start by writing the coefficient, which are the numbers other than all those extra zeros. So here we have a 3, 3, and a 5, and then all the string of zeros begin. So what we're going to do is we're going to write the first number and then put a decimal point after it. So 3 and then a decimal point. Then we're going to put a decimal point, then we're going to put the rest of the numbers, 3, 5. So we'll have 3.35. Now this is because with scientific notation, the coefficient has to be greater than or equal to 1, but less than 10. So it can be 1, but it can't be 10. It can be 1 all the way up to 9.99999, however many nines you want. Now watch what happens when we multiply the coefficient by 10. So when we multiply 3.35 by 10, the decimal place jumps by 1 spot to the right. So 3.35 times 10 becomes 33.5. If we multiply by 10 again, the decimal place jumps by 1 more spot. So you're not going to normally see a decimal after integers like 335, but it's still there. It's kind of hiding. We can repeat this process to get larger and larger numbers. What we can see is that the more times we multiply by 10, the more our result gets larger and closer to our original huge number. Of course, all those times 10s times 10s times 10s start getting just as cumbersome to deal with, so we're going to use exponents to abbreviate. Every time we multiply by 10, we increase the exponent by 1. We do something similar with really small numbers, but instead of multiplying by 10, we divide by 10. And we use negative exponents to indicate how many times the decimal moves to the left, the other direction. So to write this number in scientific notation, we start with the first number, the coefficient, which is 6, put a decimal point, and then write the rest of the numbers that appear, 6, 4, 5. So we have 6.645 as our coefficient. The next step is to draw a decimal point on the original number in the same place as the decimal appears in the coefficient. Then what we're going to do is we're going to count the number of jumps to get back to the original decimal point. When I say jumps, what I really mean is the number of times we're dividing by 10, because each time we divide by 10, you increase the exponent, making sure the exponent is negative. We have to divide 6.645 by 10 27 times. So we rewrite the original number as 6.645 times 10 to the negative 27th. In other words, it jumps 27 times to the left to get back to the original decimal place. So now it's your turn to try a problem. This problem is like the one we just did. Notice that we're dealing with a number smaller than 1. That should tell you something about the sign, whether it's positive or negative, for the power of 10. So go ahead and pause the video now, and we'll go over the answer when you're ready. Okay, welcome back. The answer you should have gotten is 4.03 times 10 to the negative 4. So let's go over how we got that answer. We're going to start by writing the coefficient, which is 4.03. I write the first number 4, and then I put a decimal point, and then 0, 3. Notice we include this 0 because it's between two non-zero numbers, 4 and 3. Then I'm going to draw a decimal point in the original number, just like it appears in the coefficient, 4.03. Next, I'm going to count the number of jumps to get to the original decimal point on the left. So I'm going from our new decimal point back to our original decimal point. I made 4 jumps to the left, which means I divided 4.03 by 10 4 times. Therefore, our exponent is going to be negative 4. So 4.03 times 10 to the negative 4.